We didn't. Just leave it. It's okay. You should have an extra. Okay, so logarithms. This is just a brief introduction on what they are, okay, how to read them, okay. Logarithms and exponents, though, are inverses of each other. Yep, inverses or opposites, right? Those mean the same thing. Just like add and subtract are opposites, multiply and divide, like a square root and square, opposites of each other. Bless you. So let's look at this example. All right, say we have 3 times 5 we know is 15. Is there another way to write that as a division problem? Yeah, 15 divided by 3 is 5, right? So these two equations saying the same thing? Yes, they are, right? They're just opposite operations, but they're involving the same numbers. Well, that's how logarithms and exponents are related to each other. So if we have the equation 2 to the third power equals 8, right? That is true. So 2 to the third power is 8. We can write that same equation as a logarithm. Now, this 3 we know is called the exponent, right? Do you remember what this number is called? Starts with a B. Base. It is called the base, right? So base number, the little one up there is the exponent. We knew that. So now when we write that same equation as a logarithm, it writes like this. We write log for just to shorten logarithm, right? So we write log, and what is the base of this again? 2. So we write log base 2 of 8 equals the 3. So how we read that as is we read that as 2 to the third power equals the 8. Okay, listen, just give me some time, patience. It's brand new. Okay, so the answer to a logarithm is the exponent. So the answer to the logarithm is the exponent. So that's why the 3, which is the answer, is the same as the exponent in this problem. Okay, so it's 2, so we read it as 2 to this power equals this number. Okay, now, all right, just, what?
No, it's easy. Why do we gotta do it? Why can't we just write 2 to the third equals 8?
Because we need inverses. Everything needs its opposite. No? No. You guys, there's much worse we could do. Do you want me to go back to rational equations? Okay, there we go. So let's listen. Okay, so let's write these two examples for me, please. And we read this as, so I'm writing it how we would read this, okay? So I'm going to write it as log base 144 of 12 equals 1/2. That's how you would read that. No, I'm just let me do my job, okay? So log base 144 of 12 equals 1/2. That's how we say that problem. Now what we are going to do is we are going to write that equation from a logarithm form to exponential form, so as an exponent. Okay, go ahead and write down both examples right now, though, number 1 and 2. All right, so this same problem as an exponent can be written. First of all, what number is the base of the logarithm?
144.
144. So we know 144 is the base. We have an exponent here equals something. So which one's the exponent? Which one's? So is 1/2 the exponent? Okay, so it's 144 to the 1/2 power equals the 12. Because 144 to the 1/2 power equals 12, right? And I want you to know something, or review something, it should be review. 1/2 power is the same as square root. So the square root of 144 is 12, and 144 to 1/2 power is 12. Those are the same thing. 1/2 power and square root, okay? All right, now let's read number 2 together. Log base of... Awesome, you guys are so good. Okay, so how would we write that as an exponent? 18 squared equals 324. Easy enough, right? So 18 to this power equals that. Okay, now let's do the opposite. Now let's go from exponents to logarithm, okay? So write down 3 and 4, please. Once you have them written as a logarithm, I'd like you to compare your answers with your neighbor. See if you have the same thing, discuss it. All right, what is the base of this logarithm, Ridge?
8.
8. So log base 8 of
8.
equals 1. So what happens when the base of the logarithm and this number are the same thing? It will, do you think it will always equal 1?
Wait, that's how we write it. Yes.
Yes, that's how you write it.
Yes.
Yes, it will. Why? Why will it always equal 1? What?
Square root of 1 does nothing.
Not square root of 1, but the exponent of 1, right? So anything, any number to the exponent of 1 will be itself, right? Jarek's going to put his chair down. So 125 to the first power is 125, right? 10 to the first power is 10. So if the base of this and this are the same, it always equals 1. Okay? What about this one? Be log base what? Log base 19 of 361 equals the 2. Good. Now let's try figuring out the answers to logarithms without a calculator. So let's try this. No whining. Here we go. Okay, number 5. Go ahead and write this down for me, please. Log base 14 of 14. Write it down. Don't say the answer. Shh, did you hear me say don't say the answer? I said write it down. Thank you. Jarek, why is it 1? Because 14 to the first power equals 14, right? Okay, what about this one? Log base 15 of 225. So think 15 to what power equals 225? That's what you should be thinking. 15 to what power is 225?
I can figure it out.
14 by 35.
What do you think it is? 15 to what power is 225?
15.
It's 2. 15 squared is 225. Yeah, 15 times 15, right, is 225. So that's 15 squared. So answer to that is 2. All right, now let's do number 7. What about log base 9 of 1 over 81? So log base 9 of 1 over 81.
Why do they gotta get fractions?
But let me show you something, though. 9 squared is 81, correct? Okay. So, well, actually, let me show you a different problem. That way you can... Okay, 3 squared is 9, correct? 3 to the negative second power is 1 over 3 squared. It becomes a fraction, so it'd be just 1 over 9. So that's all it does. It just makes it a fraction.
Negative.
So what is this going to be?
Negative
No, you guys are thinking 9 times 9 is 81, but think this is an exponent, so it's negative 2. Because 9 squared is 81, right? So 9 to the negative second power would be 1 over 81. Okay, do not think this times this is this. No, this to this power is that. Okay? All right, let's do 2 more. Log of 1. What is the base? Is there a little base number there? No, there's not. So whenever there's not a base number there, with logarithm, it is always 10. The default is 10. That is because we live in a 10 base world, right? 10 pennies in a dime, 10 dimes in a dollar, right? Base 10 until we did like feet and inches and all.
4 quarters is $1.
Quarters are 25 cents. That's not a power of 10. So 10 to what power equals 1? What did you say, Hennessy? 0. 10 to the 0 power equals 1. So anything to the 0 power equals 1 except 0 to the 0. 0 to the 0 is just 0. But anything to the 0 power is 1. So whenever you have log of whatever of 1, what will it always be? 0. Okay, last one. This one's tricky. Let's see who can figure this one out. Log base 49 of 1/7. Write it down. Yeah. Close. You think along the same lines. But remember, 49 squared is not 7. But the square root of 49 is 7, right? And so what exponent is the same as square root? 1/2. So what will it be? If it's a fraction, negative 1/2. There you go. Okay? So it's negative because of the fraction, and it's because of the fraction here. And then it's the 1/2 because 49 to the 1/2 power is 7, right? So that's how we get the 7, and then the negative comes in because this is a fraction. Okay? So what I want you to do is I want you to think. What if I have this one right here? Log base 9 of 81. 9 to the what power is 81? 2, right? That's easy. What about this one? Log base 10 of 10. 1, right? Whenever these match, it's always 1. What if it was log base 8 of 1? 0, right? Whenever this is 1, it's 0. Now, what I want you to do is have you ever played war, like with playing cards? Right? Whoever has the highest number takes the cards, and whoever ends up with the most amount of cards at the end wins, right? So, what? If you get the same number, what happens?
You have to lay down 3 and whichever is the higher.
Yeah, so you lay down 3 face down, and then you flip over the 4th one. The highest out of those takes all of them, right? Has everyone played war? Okay. All right. I want you to partner up in your groups of 4, and then I'm going to pass out the cards to you.